Hello students, welcome to AcadShala.
Let's roll on with 3R series, that is recall, revise, retrieve.
Today we are going to do numericals part 2 from chapter 12, electricity.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all.
Students, we have done numerical 1, numerical 2 in the last video. Today we are going to continue with numerical number 3. So let's read. Find the work done in moving a charge of 2 coulomb from a point at higher potential 6 volt to lower one at 4 volts. Now what is given in the numerical? This is the first step always, children, I tell you to write it. So we have Q, that is given the charge, that is 2 coulomb, I have written. And what is given? That is the lower potential. This VL is known as lower potential, which is given 4V, I have written over here. VH is also given in the numerical, which is known as higher potential. The value comes out to be 6V. I have written all these 3 values, which is given in the numerical. Now what I have to find out? I have to find out the work done. So I have written W, that is question mark, that this I have to find out. Correct. Now I will also make this according to the demand in the numerical, that they are saying that a charge of 2 coulomb, that is moving, that is 6V to 4V, that is from higher potential to lower potential, and values I have written it over here. Correct. Now I know the formula also, that W upon Q is equal to, that is delta V. What is this delta V? That is the difference between the what? From the final and the initial position of what? Of the potential difference, that is of the potential. Okay. Now after knowing the values, the formula, that is W upon Q is equal to delta V, I have written. So I can also write, instead of delta V, that is VF minus VI, that is final minus initial. So W upon Q is equal to VF minus VI. Now I know the value of this also, because I know the lower potential and the higher potential. So the value comes out to be as 2. If the value comes out to be in negative also, no need to worry. So don't worry about it. Only concentrate on the value which is coming out. So after this, I know the value of this. So I have written 2 over here, and W I have to find out, and 2, that is, it is of Q, that is the charge. So I have written the value of Q over here. Solve it, children. So it's very simple numerical. So the work done comes out to be 444 joules. 4 joules. Children, always and always remember that when you write an answer, always write the units. Otherwise, your marks will be deducted if you do not write the unit. Very important. Very, very important. What is given in the numerical, please do write. What you have to find out, please do write. What you know about the demand in the numerical, the formula, please do write. Solve it, put the value, solve in simplified manner and take out the answer, but write the unit. Very, very important. Okay, let's proceed to the next numerical, number 4. Numerical says, a wire of resistance, that is 5 ohms, is folded once to half its length. Please concentrate on the language, what they are saying. Find the new resistance. Okay, so I am saying that there are 2 cases in this, which I really feel it is there in the numerical. Okay, but how? That I have to solve it. That means in the first case, I have a wire, simple wire, kept it. In the second case, I have folded this wire like this, that is in a U shape like this. I mean to say, First case, the wire was like this. Then I have folded this wire into like this. This is what they are saying in the numerical. That is, I have folded once. So see the word children over here in the numerical. Folded once to half. That is like this. I have folded. I've come to know what is the demand in the numerical. So I have placed the two cases over here in front of me. Okay, in the first case, let me check what is given. So R1, that is the 5 ohms given in the numerical, fine. Okay, I've written over here. Length and area, let us suppose ourselves only to solve the numerical. Okay, so let us do in the first case, L1, that is the length is equal to L, and A1, that is the area is equal to A in the first case. Done. Okay, now to find the resistivity. Now, what I am seeing in the numerical again, that the resistivity will be same again. Why? Because in both the cases, the wire was same. But the only difference was that it changed its shape. That means I have folded according to the demand in the question. But they never said, they never touched to that point. They only said that the wire is folded once to half. But they never said that the material is different. No, the material is same. The material is same, but only it is folded once to half its length. Correct? If the material is same, of course, concept says the resistivity will be same. This is the first thing I should know now. Okay. Now I know the formula also. In the first case, I will put up that is R1 is equal to rho L upon A. Okay, I will put the value of resistance, that is 5 ohms according to the demand in the numerical. I will put the value 5 over here, fine. And then rho L upon A. Okay, now 5A is equal to rho L. And to take out the value of rho, immediately I have taken out that is rho is equal to 5A upon L. So I have come to know the value of rho from the first case. Finished. Okay. Now let us come to the second case. The second case says that I have folded once to half its length. Okay, I have folded. Now, is there any difference in something? Yes, there will be a difference in the second case. But what? How? Okay. I know the formula I have put up for the second case, that is R2 is equal to rho. Why rho here and rho here? Because resistivity is same. Okay, fine. L2 upon A2. Why this is? Because these two will be different. That is length, they are saying to half its length. So L2 in case of the second case, it will be L upon 2. Fine. Area, that means A2 will be 2A. That is the cross section area is doubled. See over here, children. Yes or no? There is a thickness in this. So that means the cross section area increased, doubled than the first. Okay. So after this, so these two things you have to keep it in mind. First, resistivity same because material is same. In both the cases, materials are same. Okay. Now, in the second case, we have to think about what will happen if we fold the wire. Of course, length will be different. I have come to know according to the numerical also given, that is hidden it is given in the numerical. That means it will become half its length, that is L upon 2. Fine. I have written it over here according to the demand in the numerical. And I have also come to know that if the wire is doubled, of course, there is a cross-section area which is now different, which I'm seeing in the second case. Of course, cross-section area is doubled. Okay, then after knowing these two things are becoming different in second case, I will put these values in this formula. I'm keeping it, that is R2 is equal to rho value. From where it has come? It has come from case 1. I've taken this value, I have placed it over here. Okay, now what about L2? L2 is L upon 2. I have put up the value over here, L upon 2. What about A2? A2 is 2A, that is 2A area. So I've kept up the value 2A instead of A2. Fine. After putting the values, all the values in this formula, let me simplify it. After simplification, after cancellation, simplification, I have come to know my value, my answer comes out to be for the new resistance is, that is R2 is equal to 5 upon 4. This is the way I have calculated my new resistance after putting up the two cases, that is case 1 and case 2, according to the demand in the numerical. Whatever the numerical says, the first case I have taken up all the values, resistivity same because the material is same in both the cases. My first concept done. Second case says it has become folded, that is halved its length. It is telling me only in the numerical half its length. So what I have done immediately, according to the demand in the second case, L2 is equal to L upon 2. Fine. And about the cross section area, of course, when I have folded it, this wire becomes little bit width. That is, you are seeing the width. So that means the cross section area is doubled. So putting the value of length and area and the resistivity, I get the answer as 5 upon 4. That is the new resistance answer. See children, if the concepts are clear, you can place the concepts in the numerical step by step and then calculate, and then your numerical is done with no error, with no mistake. Always keep it in mind. Always remember children, no matter it is physics or maths. See children, numericals are there in physics and your problem solving, your sums and all in maths. So the criteria should remain the same, that whatever is given in sum or numerical, write down. What you have to find out, please put a question mark. Now which formula you have to put it according to the demand in the sum or the numerical, please go ahead, but always keep it in mind. The units and of course the conversion of your units, very important in your maths as well as in physics. Okay, now the fifth numerical says two wires having same length but different radius, R1 and R2. Okay, find the ratio of their resistance and resistivity if they are made up of same material. Okay, fine. Now the first criteria, we will see it in the numerical. They have told us bluntly and frankly in front of us that it is made up of same material. If it is made up of same material, that means resistivity same because material of the conductors same in both the cases. This we have come to know directly. So we are very clear about our resistivity. Now I have drawn the wires over here. Okay, they are saying it is of same material. Okay, let us take an example, say silver. Okay, this is also silver, this is also silver, because in the numerical they are saying made up of same material, but they have not told which material, but we will take it on our own that I take it as silver and this also as silver, because in the numerical they are saying that the material is same. Fine, material same, resistivity same. This we are clear about our concept. Okay, in the first case, that is the radius R1 I have written. Okay, what we have to find out, that is the resistivity and the resistance, but what I have to find out, the ratio, because they have written clearly find the ratio of the resistance and resistivity. Okay, so I have written over here that if for both the cases, in both the cases I have to find out the ratio for resistance and resistivity. Okay, now if I know that the resistivity is same, so that means over here rho 1 is equal to rho. Okay, and over here also rho 2 is equal to rho, because I have come to know about the concept resistivity will be same. So now very simple, I have to take out the ratio of resistivity. Okay, so I will put up rho 1 upon rho 2 is equal to, because it is rho, so rho upon rho. Why? Because resistivity is same. So it will come out to be 1:1. That is, it is the ratio of resistivity, that is 1:1. Clear children? So this we have solved about the resistivity of the ratio, that is 1:1. Now let us come to the second case, that is about the resistance. Now in this case children, how we have come to know that the area will be different or same? Of course, it is very, very simple. From the numerical is telling itself that it is having radius R1 and R2. If we are knowing that the radius is R1 and R2, that means area in both the cases are different, because radius is different in both the cases. Yes or no children? So in this case, what will happen? That length is same, that is L1 is equal to L, L2 is equal to L, but the material is also same. This though we know it very well. Okay, in the second case, now I know the resistivity is same. So I've taken out the ratio of resistivity. It's all done. Okay, now I will concentrate on the resistance. Okay, so the formula that is R is equal to rho L upon A. Now what I will do? Now I have come to know that this rho is same, fine. This length is same, fine. Because I have come to know from the numerical, rho is same because I have solved in case 1. Because material is same, so resistivity is same. Length is same because I know from the numerical only. L1 is L and L2 is L and material is same in both the cases. When these things are same, what I will do, rho and length factor, I will remove it because they were same in both the cases. So I will remove this. Fine. After removing this, now I will concentrate only on resistance and area. Now I have also come to know that area will be different in both the cases. Why? How I have come to know? Because the radius are different over here, because in the numerical only it is written R1 and R2. From here I have found that is the area is different in the second case. Okay, so what will happen after removing this rho and L factor because they are same? So I'm left out with R is equal to A. Okay, now what is the criteria demand in the numerical? I have to find out the ratio of resistance. Resistivity we have taken out. So now I have to take out the ratio of their resistance. Okay, so R1 is the resistance 1 upon now area formula, that is pi R square is the formula. So in the first case I will take out R1 is equal to 1 upon pi R1 square. So in the second case R2 is equal to 1 upon pi R2 square. So these two values we have come to know in both the cases. Now find out the ratio. I have to find out the ratio of resistance. So what I will do, R1 upon R2. Okay, after this I will put up the values of R1 and R2. Put the values, and then after putting the values, children, are you seeing it over here? After putting the values, this pi will get cancelled. The value which will come out to be in the last will be R2 square upon R1 square. So I have now calculated the ratio of their resistance also. So ratio of the resistance comes out to be R1 upon R2 is equal to R2 square upon R1 square. And the ratio of the resistivity comes out to be 1:1. So this is the way you have to solve the numericals, children, one by one with the concept one by one. Place the concepts at every step and solve it. See, the resistivity is same. Why? Because the materials are same. Now, areas are different. Why? Because something is given in the numerical. They are telling you that why the area will be different. But these things are, children, hidden in the numerical. That you have to take out, because how you have come to know about the areas are different? Because of this radius. Of course, this is a very common sense thing. Radius, it is different. So that means area is also different. Finished. So we have come to know indirectly from the numerical, that is, the hidden answers are there in the numerical too. That you have to take out with the demand in the question, with the language of the question. So you have to understand the language of the numerical, the demand of the numerical with your previous knowledge and your concepts. Again, I'm saying your concepts should be clear. Then only you can do the numericals. And your calculation part should also be a little bit strong, so that you also save time in solving the numerical. That also plays a vital role for solving the numericals or the sums. Right, children? So always keep it in mind, the concepts, the conversion things, and what concepts you have to place it in the numerical to solve the same. So with this, children, I wind up the session. Bye-bye. Good day. God bless.